Okay, so we're going to start with kinetics here on lesson 2. Kinetics is obviously, as you can read there, has all has to do with how fast a reaction goes. Um, Reactions in chemistry are measured by the change in the concentration. So when we're talking about kinetics, it's the concentration per second, and the concentration is how much of that stuff is changed per second. And the term is molarity. We've talked about molarity real briefly. But before we get to that part, let's talk about how it's actually done. So, in order to have a reaction, you must have an effective collision. That's how it determines whether a reaction is going to even occur or not. So, you need two things: you need correct orientation, and you need sufficient energy. The correct orientation means those two particles that are going to react, they have to be facing in the way that they can both react. If there was two people at a party and they were going to react, they would need to be facing each other. So if they were both in the same room but not looking at each other, there would be no reaction. Another example I like to use is with trains. So if we consider this train here, that's a boxcar right there, and that there is another boxcar. Okay, if these two boxcars are on two different tracks, there's no way they are ever going to have the correct orientation to react. No way they're going to hook together. All right, this little thing here in the center. I'm going to show you this thing here. That's the coupler. That's what holds trains together. In order for the coupler, those two little fists to react, they have to have sufficient energy and correct orientation. So if you had two trains, all right, like this, two boxcars, and they are on two different tracks, there's no way they'd ever hook up. In order to have them hook up, this boxcar here needs to be on this same train track. So this end of the train is facing this end of the train. And then again, so you have the two couplers, let me show you that again. The two couplers, all right, they hook together, or they smack together, and then they link. Okay? That's how that happens. So in order for these two boxcars to have the correct, in order to react, they have to have the correct orientation. They both need to be on the same train track. If one was over here and the other one was over here, that doesn't do it. They both need to be on the same track. The other thing is they have to have sufficient energy. Sufficient energy means you have to be able to overcome this coupling process. So when these two things meet, all right, they're open. But then what happens as they move closer, they push, and as they push together, if they push hard enough, they will link like this. If they don't push hard enough, they're not going to link. And what's going to happen is they would just bump off each other and not connect, and the trains would not be connected. So that's what this whole idea of an effective collision, you have to have sufficient energy and correct orientation. The same is true in the chemical world. Those two particles, they need to be facing in the direction they need to be facing, and they have to have enough energy to overcome that activation energy we talked about before in the last lesson. So again, kinetics is how fast a reaction goes, and there's a couple different things that affect how fast a reaction goes. These are the factors that affect the rate of reaction. The first factor is the nature of the reactants. If those two reactants are not, they're not going to be able to combine. If one's a gas and one's a liquid, they're never going to react. If one's a molecular solid and one's a ionic liquid, aqueous liquid, they may not react. They have to have similar nature. They have to have similar characteristics. The concentration. If you don't have a lot of something, it's not going to react. Okay, so you need a lot of, in order to have if you increase the concentration, that means the reaction is going to happen faster. That just makes sense. All right. If you're think about a fire. If you have just a little bit of oxygen, you have three things for a fire: heat, spark, and oxygen. If you have a fuel, spark, and oxygen. If you have plenty of fuel and a spark but not a lot of oxygen, that reaction will just kind of smolder and go slowly. But if you increase the concentration of the oxygen, that reaction is going to go much faster, and now you have a much more vigorous fire. Surface area. This is kind of a tricky thing because surface area and particle size, they are kind of opposite. The surface area, the more surface area you have, the faster the reaction goes. Anyone who's ever made hot cocoa knows this. If you dump out your hot cocoa and it's kind of all conglomerated together or stuck together in a big block, it's not going to dissolve in your hot water real quickly. All right. You want to have it as a powder. The powder will dissolve quickly. A chunk of hot cocoa would not dissolve quickly. So that's why they powder the hot cocoa and make it so it has a lot of surface area, very, very small particle size. Another factor that affects how fast a reaction occurs is pressure, but that only works for gases. Um, Pressure does not affect liquids and pressure does not affect solids. So if you're talking about increasing the pressure of two gases, they may react. We talked about the Haber process, nitrogen gas and hydrogen gas reacting together. Right? As you increase the pressure, you increase the rate of that reaction. It will make that reaction go faster. As I alluded to earlier with the hot cocoa, if you've ever tried to make cocoa with cold water, you found out that that cocoa does not dissolve real well. You have to have hot water. And so temperature is another factor that affects the rate of a reaction. If you have a low temperature, that's low average kinetic energy, it will have lower potential energy. So you want to have higher kinetic energy to make the reaction go. And then the last one here is a catalyst. If you have a catalyst in your reaction, that creates what's called an alternate pathway. And we looked at that in the last lesson. That catalyst lowers the activation energy, lowers the amount of energy necessary for that reaction needed to make that reaction occur. So if it has lower activation energy, it will go quicker than a reaction with higher activation energy. So you throw a catalyst into a reaction, that will increase the rate of reaction. So all of these things here are factors that affect the rate of the reaction. Now we would do a rates of reactions lab at this point, but for now, what I'm going to do is I'm going to give you some questions and I'm going to have you go through those. So we'll look at those next.